of invisible gamma rays would act like a science fiction death ray, ripping into the stratosphere.
You would see a very bright flash in a particular spot in the sky, like a new star, and then the whole sky would go white.
The flash comes not from the explosion itself, but from the gases in the atmosphere, which glow when attacked by the high-energy gamma rays, and start what would become an environmental disaster.
It would destroy about half of the ozone layer on the Earth. And that means that more ultraviolet radiation would be coming down and hitting the surface of the Earth, and that would have the major effect of life on Earth.
This sounds like science fiction, but it may have happened before. A new theory proposes that a gamma ray burst caused one of the worst mass extinctions in our planet's history. It happened 450 million years ago, at a time we now call the Ordovician period.
The Ordovician mass extinction is the second most severe extinction that has ever afflicted life on this planet. Far more severe than the extinction that eliminated the dinosaurs.
At the end of the Ordovician period, the land was practically bare, but the oceans were teeming with life. Then, for reasons that have yet to be fully explained, more than half of all species vanished from the face of the Earth. Recently, some scientists began considering a gamma ray burst as a possible cause. One of them is astrophysicist Brian Thomas.
In this case, we've got the beaming coming
In 2005, Thomas was studying gamma ray bursts while working on his PhD at the University of Kansas. GRBs, as they are known, are the most powerful explosions in the universe. A gamma ray burst results from the sudden collapse of a supermassive star at the end of its life. It sends out narrow jets of gamma rays, so powerful they can be detected across the entire universe.
A gamma ray burst, you're not going to see it coming. It's something that we would have little or no hope of actually defending against.
Thomas and his colleagues calculated what would happen if a GRB exploded deep in interstellar space, more than 6,000 light-years away. A light-year is the distance it takes light to travel in 1 year at the rate of 186,000 miles per second. It means the gamma ray beam takes 6,000 years to reach the Earth. But even so far away, the burst could create a grim scenario for our planet. Gamma rays were first identified in 1900, when traces of them were discovered coming from uranium. But few people paid attention to them until atomic bombs destroyed Hiroshima and Nagasaki.
Many died, and the number of deaths kept mounting from day to day.
Radiation was known to be harmful, but the deadly effects on bomb victims came as a surprise to many. The damage to human tissue caused by radiation is measured in units called REMS. A safe dose is only 5 per year. But victims within a mile of the Hiroshima bomb received 400 REMS, much of it from gamma rays. It was enough to kill 60% of them within 30 days. The estimated figure for initial deaths at Hiroshima is 66,000. Radiation deaths would raise that to more than 200,000. Gamma rays are dangerous because of their intensely high energy. They are at the extreme high end of the electromagnetic spectrum, above the most powerful X-rays, and far beyond the domain of visible light and other waves in the spectrum. Still, gamma rays from space don't penetrate to the Earth's surface.
The Earth's atmosphere is thick and shields us. And that amount of material is enough to stop any gamma rays coming from outside the Earth's atmosphere.
If a gamma ray burst were to hit the Earth, the atmosphere would take the hit for us. Environmental scientists estimate that in just 85 minutes, it would have suffered damage so grave it would take a decade to recover. The high-energy beam would blast apart molecules of the two principal gases, oxygen and nitrogen. Single atoms of each element would then be free to recombine, In the chemical chaos, nitrogen and oxygen join to form a soup of dangerous nitrogen oxide compounds.
The nitrogen oxides, both the NO and the NO2, destroy ozone catalytically, and this is something that we've known for a long time.
Atmospheric scientists also know it only takes a single molecule of nitrogen oxide to destroy up to 1,000 molecules of ozone. The gamma-ray burst modeled by the University of Kansas would destroy 40% of the ozone, our only protection against the sun's deadly ultraviolet light. UV at the surface would soar by 80%.
If you're showering the surface with lots of ultraviolet radiation, you're obviously going to kill a lot of things off right away.
Then there is nitrogen dioxide, a foul-smelling gas produced in the wake of the gamma-ray beam. Spreading worldwide, it would cover the planet in an ominous brown haze.
That brown haze would block out sunlight and would initiate a period of global cooling that could last for months and would also have quite a dire effect on life on Earth.
With such serious consequences for the planet, the University of Kansas scientists wondered what clues might be found in the fossil record to show evidence of a burst in prehistoric times.
It's not unlikely that one of these may have occurred throughout the history of life on Earth, and as we study what has happened to life throughout its history here, this is one of the pieces of the puzzle that may explain some of the mysteries that we see in the record.
Mysteries like the great mass extinctions in Earth's distant past. Thomas sought the answer from paleontologist Bruce Lieberman.
I'd never heard of a gamma-ray burst before my colleagues in the astronomy department